Next presentation is Masking Reflected DDoS Attacks by Johnathan Azaria.
Okay, hi. Is this okay? Okay, great. Hi. I'm here to talk to you about masking DDoS attacks and how to try to protect against them. Okay, now we'll start with a short disclaimer. So my actions and opinions are not a reflection of my employers. Okay, the information in this presentation is for educational purposes only, and I'm in no way responsible for how this information is used by anyone who isn't me. Okay. And just to make this crystal clear, DDoSing someone without their permission is illegal. Yes, even if we call it stress testing. Okay. So, about. My name is Johnathan Azaria. Johnny works too. I'm a security researcher at Imperva in Capsula. Okay. What we do? Web application firewalls and DDoS protection, bot protection, and some other cool stuff. Okay. What I mainly do is security research around DDoS attacks. Okay. I research DDoS attacks, how to detect them, and how to protect against them. Okay. Now, how this talk is going to work. I'm going to talk a little bit about amplification attacks. What we saw some special phenomena, so I'm going to talk about that. Talk about what we found. I'm going to do some short technical overview and a demo. Now, talking about demos, I understood that the demo god is an angry god. So I tried practicing the demo for a while. It worked for this entire week. I did all these different modifications and it kept on working. I used VPN, I used different networks. It kept on working. Today in the morning I said, let's try it again. And of course it stopped working. So I have to use a backup I have, okay? So it's not going to be entirely authentic. Now, does anyone here does anyone here not know what DDoS is? No? Okay, great. So just a very quick intro. DDoS is short for Distributed Denial of Services. The major idea is to overwhelm the victim's data pipe, okay, to bring it to a point where you just can't do anything else besides handle the data you send towards them. There's some other methods where you try to overwhelm the CPU, overwhelm as a connection table, and some other things. Okay, and one of the major things about DDoS attacks, it's very easy to execute. Okay, a lot of script kiddies do that. Anyone can do that. There are tons of DDoS tools out there. You can just download to your computer, press a few buttons, and that's it. It starts working, and you can flood a victim. And another thing, the industry of protection and mitigation against DDoS is worth a lot, over $1 billion during 2017. And there's also another industry around DDoS where you can actually have DDoS for hire. Okay, you can hire someone to attack your victim. You pay, you have all these funny subscriptions program. You have 1 month, 2 months, a lifetime, and all these different things. You can get a certain amount of concurrent attacks at the same time. You have 24/7 support and all these different things, okay? It's a very thriving industry. Now, let's do a very small presentation of what DDoS is. You have a victim. Let's say he has a pipe size of 15 megabits per second, and he wants to watch his favorite show, okay? Now, you gather around with some of your friends and you say, well, I don't like that guy so much. Let's stop him from watching this show. I'm going to show him what a true hacker looks like. So you get your friends, and each one of you don't have such a big bandwidth, each one of you, but altogether, you can sum it up to over 50 megabits per second, and now your victim can't watch his show anymore. Okay, so that's the basic idea around DDoSing someone. Okay, now let's talk about DDoS amplification attack. Okay, so this is a small presentation. So the idea is like this. when you talk about DDoS amplification, what you do is that you exploit a server that tends to respond with a response that's much larger than the request, okay, in order to amplify your attack against the target. In other words, the vulnerable, computer or the server that has the vulnerability isn't the one you attack. You just use it in order to attack the victim. Now, this is kind of special because you don't exactly see it. It's not very common in different attacks. Usually, if someone is vulnerable, you use that vulnerability against them. But this is not the case in amplification attack. Okay, now, there are some prerequisites for an amplification attack. You must have a service that responds with a very large payload, okay? So you send it a small packet and it responds with a very large packet. Usually when it's above a amplification factor of 5, so the response is 5 times larger than the request, then you consider it an amplification attack. You must work with a spoofable protocol, okay, because the concept is that you spoof the victim's IP. So if you work with a protocol that requires some sort of a handshake, authentication of any sorts, so it's not really possible. And the service must be open to the world, okay? If it's opened internally, then you might be able to DDoS your colleague, but if you want to DDoS actual people in the real world, you have the service, you have to have the service open to the world. Now let's do a small example, just so that you see. This is what an hex dump of an NTP request looks like. And this is what the response looks like. Okay, in this case, you got the 17 amplification factor, but NTP can get up to 556. Okay, so that's a major amplification factor. Now let's do a small attack flow. Let's say you have an attacker and you have a victim. Now the attacker can send only up to 5 megabits per second. Now usually this won't be enough to cause any server to fall, right? 5 megabits per second is barely anything. So the attacker goes and Shodan, and he finds this bunch of nice NTP servers that respond to his request. Now, he can send a request to these servers while spoofing the victim's IP. The server will respond to the victim because this is UDP, so he thinks the victim send this request. And because we said we have about 556 amplification factor, from 5 megabits per second, we reach up to 2.5 gigabits per second, which will probably smash the victim's server. Now the victim is hit. You repeat again and again until the victim is down. Okay? So this way you can see how one single attacker can actually cause a lot of damage and make a server go down without needing any friends, without really needing anything besides knowing what servers will respond to his request. Okay, so now let's talk about how do you detect these kind of amplification attacks. So does anyone know what's the easiest way to detect an amplification attack? Anyone? Okay. So one of the easiest ways, because we said these are services, okay? These services are open to the world, like NTP and DNS and some other services. They're well known. They have to publish themselves, and they usually work over a very specific protocol, and over a very specific port. Okay, so let's say DNS works over port 53. NTP works over port 123. So the easiest way to detect you have an amplification attack coming in your way is just looking at the source port of whoever sent the packet. Okay, just look at the source port of the packet, and you can realize this is an amplification attack. Now, another option, as I said, because these services are published, you can just find an IP list of most of them. You can compose it by looking at Shodan, looking at some other sources, and just find an IP list of all these different services in such a way that you can know that when you get traffic from this IP, it's probably an amplification attack. And the last thing, this is very general to DDoS, you can just look at IPs that are high rate, that they fire way more than they should have fired. In other words, you see an IP that sends more traffic at you than you would expect. Now this usually isn't very easy to detect. Okay, you have to have some sort of a mechanism that does that knows what's supposed to happen, what actually happens. Okay? Now what I'm here to talk about is that this isn't always the case. Okay? you can't always rely on source port or on an IP list to mitigate amplification attacks. Now, what did we see? As part of my job as a security researcher, looking at DDoS attacks, we have all these different attacks coming at our way, and we need to look at them and we need to see what happened there and how we can prevent it from happening again, and what kind of mechanism, what kind of rules we can put in that will prevent these attacks from happening. Okay? So we saw an amplification attack coming from non-trivial source ports. Okay? We expected this attack, as I previously said, we expected this attack to come from a specific source port, and it came from other source ports. Now, it was coupled with the trivial source ports, but with other source ports as well. As we said, this is not expected. You usually don't think that an amplification attack will come from different source ports. Now, the attack was very high volume, so it wasn't some kind of fluke that you just cut a few packets from, I don't know, some services that act very strangely. As you can see here, this is a very peaky traffic. And we said, okay, so we got this attack, let's try to replicate it. Let's see if we can do it again. So we look at the IPs that sent the attack, and we try to send packets at their way and see if we get any response, but we couldn't really get anything back. Okay, we sent and we did all these different variations, but nothing happened. So we said, okay, let's do the next logical thing. Let's try and replicate it in an internal network. Okay, specifically, this amplification attack came from devices that usually you have them in your internal network, so we said, okay, let's try to replicate it. But once again, we didn't manage. This case, I think it's because my workplace has like these crazy security rules, so nothing really works in the internal network unless someone predefined it. So we said, okay, what are we going to do? What kind of network do we have in our area that isn't as secure? So we said, okay, let's go to the local coffee house. It's right over there. So we went downstairs to our local coffee house, and we connected to the Wi-Fi, and we tried doing the same thing. We sent some packets, and we got a response. And we didn't expect it, but the response came from a port we didn't expect it to come from. It came from a non-trivial source port. Now, the amplification vector I'm talking about is called UPnP, and specifically the protocol is called SSDP. I guess some of you, most of you heard about it. Okay. SSDP is short for Simple Service Discovery Protocol, and UPnP is short for Universal Plug and Play. It's an extension of the existing plug and play, you know, what you use when you plug your USB into a computer and then you can use your mouse. So this is kind of an extension of that service. Now, SSDP is what's being used by UPnP devices to discover one another, okay? And it works over UDP 1900. And as you can expect, you can use it to trigger a massive response. Okay, it's a very popular DDoS technique. What happens is that you have a lot of IGD, Internet Gateway devices that have UPnP, and instead of being opened internally only, they're also opened externally. So you can send a SSDP packet to them over port 1900, and they'll actually reply, even though you're coming from the external network. Now, this is as I said, this is a very popular DDoS technique. I think last month we did some kind of an internal report, and we found that this was the mostly used vector. Okay, and in general, UPnP has many security issues. You can look about it, and there's tons. Okay, anyone can go and find something vulnerable, something special in this entire protocol. Okay, there's tons of different things. There's some even a remote code execution and a bunch of other vulnerabilities. Okay. So let's explain very quickly what is UPnP and SSDP and what is it used for. Okay, so let's say you have a computer and you got this amazing smart TV. Now you want to stream data from your computer to the TV. Okay. Now instead of plugging a cable, you want something that will work very easily. So this is what UPnP and SSDP is for. Your computer joins a multicast IP group on your router, and the smart TV does the same thing. Okay? Now, your computer can send a search packet to this multicast IP group, and the router will send it all over to whoever is in the group. Now, the TV gets the search packet, and it returns to the computer a scheme, okay, UPnP scheme. Now, what this scheme does is that it allows the laptop to understand how to operate the smart TV and how to send different commands to it. Now, the computer reads the scheme, understands it, and now it can stream media to the smart TV, and once again, you can watch your favorite show, okay? Now, what happens if one day your TV breaks down and you decide to buy a new TV, okay? A much better TV, one that's way better than the one you already had, okay? So, what's amazing here is because if they have the same UPnP profile, they work in the same way, this whole process can happen again, and as far as you're concerned, you plug in the new TV, and you can start immediately streaming media, and once again, watching your favorite show. Okay, so the idea is it's great. I mean, it's like the plug and play with mouses and keyboards and whatever. You just plug in the smart TV and everything works. Now, of course, something had to be compromised to reach this kind of a seamless connectivity, and that thing is security, obviously. So, here's what we found. There's a way to use this UPnP, and specifically UPnP and Internet Gateway Devices and IGDs, to proxy requests throughout the Internet, okay? Now, these IGDs can be remotely accessed, okay, so accessed from the external network. They can be found using shutdown, okay? You can use a very simple command to access them via shutdown. And this is the interesting things. These devices, they have the ability to set port forwarding rules, and that is part of their UPnP scheme. So it means you can just go to this device and change its port forwarding rules as long as you know how to. So, what's the idea behind this, and how can this be used for DDoS? So let's say you have this attacker and you have this victim. Now, the attacker has been abusing the victim for a while now, okay? He used all these different amplification vectors, and he kept on attacking him for a very long time. At some point, the victim was very tired, so he called his ISP and he said, well, please block all these different ports, okay? Block traffic from port 53, from 123, from 111, from a memcache, which is 11211, and all these different ports. And he gave his ISP this huge list of ports, told him block everything. And not only that, he said, okay, I'm going to find out all these different IPs of all these different services. I'm going to ask my ISP to block all of them as well. So he gave the ISP this huge list of ports and IPs, and now the ISP blocks almost everything for him, but he knows he's protected. Okay? So now the attacker understands that, and he tried attacking the victim, but he just couldn't because, once again, the ISP blocked everything. So he found this UPnP device on the net. Now, UPnP devices, especially these type, are household appliances, okay? Appliances used by private people in their own house. In many cases, once the device resets, it gets a new IP. It gets a new IP. It isn't nothing there is stable, nothing stays the same, okay? So he found this device on the internet using shutdown, and he knows a bunch of DNS servers. Now, as I said, the attacker can set a port forwarding rule on the UPnP device. What the port forwarding rule says, okay, so you can read it. What the port forwarding rule says is the following. Whatever request you get to port 1337, forward it to this DNS server over port 53. Okay, this is the port forwarding rule he set in. Now, what happens is that he can now send a DNS query to the UPnP device to port 1337. The UPnP device will forward that request to the DNS server. The DNS server will respond to the UPnP device, and because the attacker sent the request with a spoofed IP, the UPnP device will respond to the victim. Now, the victim sees an attack coming from a port source port 1337, and from an IP he doesn't know. So he cannot be protected because he doesn't know the source port and he doesn't know the IP. So this way the attacker is able to overcome all the obstacles that the victim set in place. Now, okay. So is this clear? Does this make sense? Okay, great. Now, the thing is that it doesn't have to be like that. Okay, you can even play with it a little bit more and do some other modifications. Instead of using one DNS server, okay, you can use, instead of using one UPnP device, you can use a bunch of UPnP devices, and you can set port forwarding rules in all of them to the same DNS server. Now, what this accomplishes is that now the victim sees a bunch of different IPs attacking him and a bunch of different port sources, okay? Because in each UPnP device, you can set a different source port. You don't have to stick to the same one. Now, this way, it becomes even more complicated to mitigate because you cannot see a single IP that is firing more than it should. You cannot see a single source port that even repeats itself. And the packets are coming from all these different locations. It becomes very difficult to mitigate. Now, it's not only that. You can, of course, add another server to make that modification even stronger. And you can use even a different server. So this becomes even more difficult to mitigate. Okay. Now, after we did all that research and we found all these different things in the UPnP, inside UPnP libraries, and after we found all these different options to play with UPnP devices and to achieve this, we found out what actually happened and why did we see this attack coming from different source ports, this SSDP attack coming from port 1900 and also other source ports as well. Okay? Apparently, it seems to be an out-of-the-box behavior in UPnP, some UPnP libraries. Okay, what happens is that some of them, instead of using the same connection to reply, they open a new connection. They use a new handler to reply. So they get the request, they process it, and then they open a new connection in order to respond. When they open the new connection, they just get some random ephemeral port, and they use it to respond. So that's why we've seen the behavior we've seen. But this is important, but it really doesn't matter because what we saw can actually be achieved. So now, let's try and recap. Okay, so UPnP devices can be used, IGDs that have UPnP can be used for SSDP attacks. The SSDP attacks, okay, come from port 1900, okay, and in some cases they come also from some other ports as well. This is an out-of-the-box behavior. What we found is that you are able to set port forwarding rules in such a way that intentionally the response will come from a source port that's different than 1900, and not only that, you can get a response not only from SSDP but from whatever amplification server you want to use. So now, this is a short technical overview about UPnP, in case something wasn't clear before that. So, UPnP stands for Universal Plug and Play. The idea is to allow seamless discovery and communication between different devices. As I said, you have a smart TV, you want it to talk to your computer, so this is an easy way for that to happen. You just plug them in, and they work, okay? It uses multicast for discovery, which is, again, for the sake of a seamlessness. You don't have to know another device's IP. You just have to sign into the multicast group, and that's enough. Okay, and the last thing, the way one device knows what the other device can do is by an XML that describes all the available actions. So in this case, you can see this XML over here. You can have you can add port mapping, you can delete port mapping, you can get external IP address and all these different actions. Now this is clear, okay? You can just look at the XML and see all these different available actions. So what's SSDP? Simple Service Discovery Protocol. It works with HTTP over UDP. It's kind of a strange beast. This is how an HTTP-U packet looks like. As you can see, it looks very similar to HTTP, but this is actually over UDP. It operates over port 1900 and subscription and discovery via multicast IP, as I previously said. Now, this is intended for internal networks only. You want your smart TV to talk to your computer, not to your neighbor's computer, okay? And even though it's intended for internal networks only, it tends to be open to the world. Many UPnP devices are open externally, and you can actually access them from the external network. SSDP has an amplification factor of 30, and this is how a search request looks like. So when you have one device that wants to discover another device, it sends this search request, and this is the response that it gets. The response has all these different details about the device. As you can see, there's a lot of details that don't really matter. What's important is that you have this location. Okay, the location says where the XML sits. Now, as I previously said, this XML describes what you can do with the device. It describes all these different options that are available, and its location is right over here. Now, as you can see, this is an internal IP. Okay, 127. This is an internal IP. Now, in this case, we have a 30 amplification factor. So you send this request, and you get back a response that's 30 times larger than the request. Now, I'm going to talk about controlling the device, but I think, okay, I'm going to do this, and then we're going to go and show it in a kind of a live way. So you send the search packet to the site that's called UPnP.poc over port 1900. Okay, and you get back this response. Now, as you can obviously see, this is an internal IP. Okay, so how can you access an internal IP from an external? Okay, how can you do that? So there's something very interesting that I can't explain, but for some reason, this isn't open only in the external, only on the internal network, but also on the external network. So what you can actually do is you can take the port and the XML location, you can take the URL, and you can take the site's IP and squish them together, and for some unknown reason, this actually works. Okay, so let's try and show that in a specific way. Just to be pretty. This is some Docker with UPnP on it. I'm going to turn on the UPnP. Okay, and now UPnP is running. Okay. Now, this is the site, and you can actually access the XML. Okay, this is what the XML looks like. Now you can see all these different details. This is a UPnP device. Okay, you can see all these different details about the device. And what's interesting is that over here you have this specific URL, which you can use to see all the different actions that are available in the device. Okay. So, as you see, you can have a set connection, get connection, type info, and all these different actions that are available. Now, this is human readable form, okay? You don't even have to understand anything. You can just go into the XML and you can read all these different things and maybe find some other use for all of them, okay? Now, of course, what I'm showing you is something, some kind of a Docker. It's something private that you can't really access. But truth is, you can actually find these devices yourself using Shodan. Okay, you can just search for one of these suffix. Okay, in this case, gatedisk.xml, but any other thing you want to. And now you can actually see there's a bunch of results, and you can see all these different devices located all over the world. You can try to access them. Of course, you shouldn't, but you can try. And you can look there and you can see if you can do all these different actions with them. This is completely public as far as Shodan is concerned. I mean, this is not information that someone is hiding. You can actually access it very easily. Okay? So, this is all these different things we just saw. Okay, so how do you control the device? As I said, this URL contains all the different actions you can do with a device. Okay, you need to build a specific request, which I'll explain in a minute. But you need to build a specific request, okay, and send it to this URL, and you have to add a specific header that's called SOAP action, okay, and put this this line in the header with the service name together. Okay, so this is what the request looks like. Okay, you have the what you want to do, which is add port mapping, okay, and all these different details. Now, what's interesting is that you don't even need to change this from one device to another. You can actually use the same request over and over. So let's say you want to do some kind of attack, you can use this request, and you can go to Shodan, and you can get a list of devices, and you can just run all over them. You can just run through all these different devices and send this packet to all these different devices and do this configuration very easily. You don't have to do this manually. You don't have to explore each one by yourself. Once you get a specific packet that works, you can run over whatever devices you want to. Okay, as long as they use the same profile. Okay. So now you'd expect this has some sort of authentication. You'd expect that you have some kind of password protection, anything like that. But the truth is that no, there's nothing. Okay, no kind of authentication whatsoever. Specifically, changing the configuration requires you to do some sort of a TCP connection. But besides that, there really isn't anything. You can, if you find a device in the network, you can go to it and you can change it. Okay, it's very, very simple, very easy. Nothing is gonna stop you from doing that. Okay. Now another thing that I didn't explain. Okay, I think I'm gonna go back and show it. Is that specifically when we talk about adding port mapping? Okay, as you can see, this is new external port. Okay, new protocol. And this says new internal port and new internal client. Now what I talked about is proxying the request to an external port, right, 53, and an external client, which is the DNS server. But somehow this still works. Why is that? Because the devices don't even validate input. So it gets an IP, which is clearly external, but it's still going to use it anyway. It doesn't even check. It doesn't try to see if something doesn't fit. It just works with it, and that's it. Okay, so as I said, some devices validate input, other devices make sure to open ports to the internal network only, but that's the most you can hope for. Okay, there's really barely any kind of a protection on these devices. Okay, so now I'm gonna do the demo I talked about. This UPnP device is hosted on a Docker, so it's kind of an internal network, so it's really not really the real thing, but that's because my droplet decided to die today morning, like I said in the beginning, so that's what we've got. Okay, so for some reason, this is this. Okay, so here's what we're gonna do. This is the UPnP device. Okay, as you can see, it's waiting for different commands to come its way. Now, I'm using a certain tool, DDoS tool called Saddam. Anyone can download it clone it from GitHub. It's very easy to operate. And I'm going to use the following command. Okay, what I'm going to do is I'm going to get a regular DNS response from Google. Okay, 8888. Okay, as you can see here, you have an amplification of 1 because I used the regular DNS query. Okay, and I got a response from Google. Now, if I try doing the same thing, okay, with the UPnP's IP, obviously, nothing is going to happen, right? Because there's no port forwarding rule yet. I didn't set anything in place, so it's not going to work. It gets a request from to port 53 and nothing happens. Now, here's what I'm doing. Here's what I'm going to do. There's another tool that downloaded from cloned it from GitHub as well. It's called part of a repository called UPnP Hackmaster, and this specifically is a port opener. Okay, what I'm going to do, I'm going to give it the UPnP device's XML. Okay, I'm going to give it a port to operate over. So this is like the 1337 we recently saw. So it's 49152. I'm going to ask it to operate over UDP. And I want it to send whatever request it gets over UDP to port 49152. I wanted to send it to Google, okay, to 8888 port 53. Okay, so I'm going to do this. And as you can see here, let's make it visible. As you can see, the port forwarding rule was set in place, okay? UDP, this is the external port. This is what the device thinks is an internal port and IP, okay? Now, if I try sending the DNS query again, this won't work. Why? Because I need to send it to port 49152. So I'm just gonna edit the script. I wanted to do it this way so that it will be visible. Usually it sends DNS to 53 and I have to change it to 152, right? Yes. So now, just so that this will be clear, I'm gonna try sending it again to Google, okay? And of course, this won't work. Google doesn't understand what's port 49152. And when I send it to the UPnP device, what will happen is that the UPnP device is going to get the request, forward it to Google, get the response back, and then forward it back to me. Okay? So as you can see, we actually got an amplification, we got the response back, and the port forwarding the request actually works. Okay? Great. So this sums up the demo. Is this understood? I mean, didn't understand what's happening here? Okay, so we actually managed to send the request through the UPnP device, get it to the DNS server, get it back, and bring it back to me. If I would send it with a spoofed IP, the response will return to the victim. Okay. So, how can you protect against this? Well, truth is that you, by yourself, you can't really protect against it because you have to get, first of all, a DDoS protection provider. But the reason you need to get a DDoS protection provider is because you need a deep packet inspection. Once you don't have the IP and you don't have the source port, you can't understand what's coming your way. And once you can't understand what's coming your way, you can't really understand this as an amplification vector. Now, most ISPs, as far as I know, don't do deep packet inspections, and you can't really ask them to do these kind of rules, to put in these kind of rules. Okay? Now, obviously, once you realized that there's a problem here, it's very easy to mitigate. You just say, if there's a mismatch between the packet type, I got, let's say, a DNS response from a port that isn't 53, okay, then I'll obviously drop it. Okay? And you can do the same thing with a source IP. Let's say if I have a list of all the different IPs, I found a mismatch between the packet type. Okay, I get a packet type from an IP that I know doesn't do DNS, but I get the DNS packet from them, then this obviously is something I want to drop. Okay, so just it was the end of it. Just a few credits. So I got the port opener from this GitHub repository, and the Saddam DDoS tool from this one. Okay, so thank you very much. Questions, anyone? Yeah.
Yeah, first, thanks for your talk. But for this reason, the port search will not be available on the internet, which raises the question of which vendors were affected, if you contact those vendors, and which devices are out there having this kind of problem.
Okay, so this is a very widespread problem. First of all, there's a bunch of devices that are vulnerable. We did not contact any of them because this is a well-known vulnerability. The UPnP devices being open to the external network is something very commonly known. One of the things that also happens is that many manufacturers just use the same library over and over again. So even if it's vulnerable, and even if they got reports it was vulnerable, they'll keep on using it. This is a very widely spread problem with UPnP. Okay? Any other questions? Yeah.
Hi. As I can see, most of these attacks rely on IP spoofing. Now, how easy it is to spoof the source IP?
It's extremely easy. It's basically you don't really need to do anything. Almost you just have to put in the spoofed IP when you send the packet, and that's it. You really don't need to know anything else.
Okay, so routers along the route of your packet, they're not going to be, they're not going to check actually that the source IP is actually outside of their range.
I'm sorry, I didn't understand that.
Well, generally speaking, yeah, you could say router on the internet, they could receive a packet from anywhere. Right, so spoofing should be easy, but in some configurations, maybe the gateway could know which addresses it actually holds in its domain. Do you see something like that on the net?
Well, if I understand the question correctly, you're asking if the different routing devices in the way can somehow discover that the IP is spoofed. Well, not as far as I know, not regular routing devices anyway. They just get the packet and they deal with it, and they completely trust it. That's why you have a protocol such as TCP, which is meant to prevent this case. But when you have a single UDP packet flowing through the network, the different routing devices just completely trust it, and they do whatever the packet sort of tells them to do. They just route it.
Yeah, okay, thanks.
Yes?
Hello, thank you. One question. If the UPnP device was the same also a DNS server, would be the attack would be the same?
Sorry,
if the UPnP device was also a DNS server?
Is also a DNS server?
Yeah. For example...
yeah, you can do, yes. You can actually do the same thing. You can tell, what you can do is you can tell the UPnP device, okay, let's say you have a UPnP device over port, over IP 1111, okay? So you can send it and set a port forwarding rule where to route any request that comes from whatever port you want to a 111 port 53. So you can actually tell it to route the request to itself, and that way you can actually use a DNS server and you get the same DNS server, but it will respond from a different port. So instead of responding from port 53, it can respond from another port. So yeah, that is possible.
Hi. I will just have addition to spoofing. Okay, technically it's not a problem to spoof the packets, but at least in my country, ISPs are already discarding the packets. They have spoofed IP addresses coming not from the IP from my routers. So I guess it's the same all around the world, or it's different, because I know from our perspective when we tried and experimented with different ISPs, we get the same results. So it's really hard. You can spoof, but the packets are not forwarded to anywhere. So.
Okay, I'm happy to hear. Whenever I tried spoofing, I never had any kind of problems, but I guess might be luck, or might be that specifically where I tried from, we didn't have that kind of technique.
Any more questions? Okay.
Okay, thank you.